Welcome to the webinar hosted jointly by Vento, Maritime and Calm Water Crisis Consulting on November the 10th, 2020. Good afternoon and welcome to the webinar, The Hurricanes, How to Reduce Risk of a Perfect Storm. I hope you can all hear me, and if you can see that I'm speaking and you don't get the sound, then please let me know in the chat box to the right. So thank you for joining. We are here to talk about this very interesting weather phenomenon that we call hurricanes or cyclones or typhoons, wherever you are in the world. And this is where we take the outset today. And then following that, we will also look at the consequences of these type of low pressures and how you can prepare yourself to be in a better place should it hit you or something similar hit you or your supply chain. So we hope that this webinar that we host jointly together between Vento Maritime and Calm Water Crisis Consulting will be relevant for all of those of you involved in the maritime industry, and of course also to those that are not, since the impact of weather can hit anybody, whether you're at sea or on shore. So who are we? Well, the webinar, as I said, is co-hosted. And representing Vento Maritime today is the Managing Director, Carsten Kofod, who will be speaking shortly. Carsten, he comes with extensive experience from the weather industry, having spent multiple years with the Danish Meteorological Institute, and now being the Managing Director of Vento Maritime, a weather service company that primarily serves the maritime industry. Myself, I represent Calm Water Crisis Consulting, and I have a background from many years with multinational companies, among those Maersk Line, where I've been working with operations, contingency handling, incident and crisis management for quite some years. And I also have a background as a naval officer in the Danish Navy, where I'm also today enrolled as a Naval Reserve Officer. We both hope that our combined experience is also reflected in what we are talking about today. There's a couple of practical details that we need to adhere to when we do these kind of seminars. If I can just move to the next one, just excuse me for a second. Here you can see myself and Carsten. Sorry that came on a little bit late. You will be able to see all the slides afterwards, so don't worry if you miss something here. There's a couple of practical details. The one is that you're all muted by default. That's the nature of the webinar format. So if you have questions as we go along, please ask them, but please use the Ask a Question button in the bottom of the screen. That way we will be able to record also the questions, and we will take them towards the end. And then we leave the chat box on the right-hand side to any technical issues that might come as we go along. The webinar will be recorded, and if you hang on where you logged in on the Crowdcast platform, you will be able to download a recording afterwards. Or you can wait a couple of days and then you will have an edited version from either available from either Vento Maritime or Calm Water Crisis Consulting. But more about that to follow, and I'm pretty sure that we will both also upload the webinars on social medias. The agenda for today, that went very fast, is about tropical storms. We will look into the 2020 season and look at the many storms that has been this year. Carsten will talk about some of the basics and how you forecast it and why they're so bloody dangerous. And then we will turn into the other part where I will talk about how that could impact your business and how you get prepared to actually counter some of these things should they happen. So here we will be talking about crisis management and risk assessment in more details. And then we round it off with a question session. And with that, I will just try to get Carsten on as a speaker. So just give me 2 seconds. And I'm inviting Carsten on here. So he should be connecting now. There we have him.
Yeah, thank you, Stefan, and thank you everybody for joining this webinar. Let me start out by saying there's a lot of type of severe weather that can affect society and commercial activities, but in light of this record-breaking 2020 tropical storm season on the Atlantic, the topic of today is, of course, regarding them. And why are tropical storms so special? Well, we have normal lows or extratropical lows that can be really dangerous with very strong winds, storm and hurricane force winds. But tropical storms have a gear or two to add to that to make them extremely dangerous. And adding to that, some uncertainty in the forecasting, predicting track and intensity. Looking at this image, these two images from Hurricane Ivan in 2004 gives a rare indication of the damage that can occur when you're hit by a tropical storm. This hurricane was Category 3, so there's a step or two stronger than that available, but yeah, this was a Category 3. This, Stefan, the next slide, please. We can have a look at the track of Ivan, which was very unusual as well. The depression was formed off the Cape Verde Islands of the Western Africa, moved through the Caribbean, made landfall in Alabama, as we saw, then crossed over the southeastern US and reformed and redeveloped, making landfall in Florida and finally in Mississippi and Mexico, in Texas, creating havoc there as well. The following year, 2005, was the previous record holder for tropical storms in a season. Throughout that year, as the new storms came, we were wondering, okay, we are running out of the predefined 21 names made available. And I think the National Hurricane Center in the US had the same concerns, and finally they come up with, okay, when we run out of names, we will add names according to Greek letters, the Greek alphabet. And this year we have managed to beat that record-setting record narrowly, but firmly. If you take the next slide, please, Stefan. Here we can see the list of all tropical storms this year. You see the first one in May, first two ones in May. You can also identify that it was the second half of the season where we had the most severe storms, reaching Category 3 and 4. Actually, this is outdated since this last night. Last night we got another tropical storm in the middle of the North Atlantic called Theta. And if anybody, I don't expect it, but if anyone is going to Madeira this weekend, be careful. But now this season is firmly the record holder. There was a small caveat with the 2005 season that a small tropical development wasn't named, but after analyzing it afterwards, it should have been named. So that's why there could be some argument of which one was the record holder. But after Theta last night, then now this is clearly the record holder. Let's have a look at the next slide where we can see the tracks of these lows, these tropical lows. And yeah, You can see the bulk of them are near the U.S., the Gulf of Mexico, and the Caribbean Sea. But in the peak of the season, we also have these the development starting off the Cape Verde Islands of Western Africa, and then the general direction to northwest, and then at some point either they dissipate or they get into the westerlies further north, and then move general direction towards northern Europe as extratropical lows at some point, with the severe weather that entails, but also adding forecast uncertainties to other lows at the same time hitting northern Europe. So they will affect the weather in northern Europe as well. So if we take a look at what are the basics about a tropical storm, what's different about them. So the next slide, please. Here we have on the top image illustration of how a normal low develops. The basis is a horizontal temperature difference between cold air to the north of a polar front and warmer, more moist air south of the polar front. And some trigger will start a circulation, and the formation will come to a tropical low, to an extratropical low with fronts as we know them, but with a certain physics involved in these low formations that differs a lot from tropical storms. So if you see on the lower image, we have the dynamics of development of tropical storms, where the key difference is that the processes involved are concerning a vertical difference in temperature, where we have evaporating hot sea surface air to get warm and moist air, and this creates heavy showers. These showers in the right conditions start to group and circulate, and if the conditions are right, this circulation can intensify, and we have a tropical depression, tropical storm, hurricane. The main difference is that we say that the core of the storm is hot, which is not the case with a normal low. So that's how we look at the differences. And let's have a look at what's required, one of the specifics needed to get a tropical storm development. Well, first of all, we have some basics. Tropical storms will not develop close to the equator because of the rotation needed to get this development requires the Coriolis force, as you may have heard of, which is generated by the rotating Earth. And the Coriolis force is not present or very low near the equator, so you need to have, we won't get any tropical developments very close to the equator. Then we have some other conditions required. We need to have unstable air. You need these thunderstorms to develop, or at least heavy showers. And another the primary constraint here is that we need sea surface temperature to be more than 26 degrees Celsius. And then if we have that condition fulfilled, then we also need that we need a weak wind shear. That means we need a quite constant wind speed throughout the atmosphere, so that we don't have a strong wind at the top of the showers. And finally, if all this is right, we need what we call a tropical disturbance or tropical wave, just a little push to get things started, and then normally with converging winds and a slightly change in pressure, and then we have it, and then it sets off. And let's have a look at the structure of it, just in broad terms in the next slide. This is a illustration of how the structure of a tropical storm or hurricane is. When we get this rotation, showers will will group and start rotating, and we'll get these, because of the rotation, we'll get showers in distinct spiral bands, and we'll get the familiar eye of the storm when it's intense enough, and the wall of this eye is where you have the strongest winds, and these processes and this structure is very different from what we will call a normal low on mid and high latitudes. And on the right, you see how we distinguish between the processes of these developments. We start with a disturbance, then we get the circulation, and we get a low depression. And when we have the strongest winds observed to be more than 34 knots or more, we call it a tropical storm. Then if we get the really strong ones, we have wind speeds of above 63 knots. We call it a tropical cyclone generically, but there are different names according to where you are in the world. Hurricane, typhoons, etc. So if we have a look at the next slide, with regards to the sea surface temperature, the primary constraint of when we can have a tropical storm formation, and we see here, that's fairly what we would consider the tropics. This is of course averaged out throughout the year, so we'll have higher surface temperatures during the northern hemisphere summer. We'll have off Western Africa and along the Gulf Stream, along the US East Coast, we'll have a larger area with above 26-degree surface water. And similarly on the southern hemisphere in their summer, we'll have an extent of hot water there. Just to give an image where we have the tropical storms, and the next slide will definitely show it. So here you can see we have very, very precisely the same areas where we have the hot water. Let's see, we'll start by North Atlantic. We have the strongest ones. The cyclones are called hurricanes here. Also on the Pacific side of the US, it's called hurricanes. Here we have the season east and west of USA is quite similar. It's defined as June till November. Many years ago, it was a shorter period. Now it's June to November, and we'll once in a while see tropical storms in the shoulder periods, and starting before and after this season. Looking at the typhoon season, when a rule of thumb is that there isn't a month where you can rule out tropical storms or typhoons. But if you should name a couple of months, then February and March will be less likely. The peak of winter. For the southern Indian Ocean and around Australia, we have a season that is in their summer, autumn, so from October till May, and in those areas we'll have this formation, and they will track westwards, and then at some point curl southward, south and southeastwards. And then I waited till last with this one. Northern Indian Ocean, the Arabian Sea, and the Bay of Bengal. It's a bit tricky because a large part of the year sea temperatures are high enough for formation of tropical storms, but because of the summer and winter monsoon, which are blocking developments, we have this wind shear problem. As I mentioned earlier, we have too blocked a weather regime for them to form. So the seasons are reduced to the transition periods between summer and winter monsoon, and winter and summer monsoon. So around April, May, and again October, November are the seasons here. Otherwise, it's rarely that the monsoon winds will allow for tropical developments. So if we go to the next slide. And now it gets a bit trickier. How to forecast tropical storms. Some of you might have seen this image before. It's from Hurricane Dorian early this season, and there was some discussion on the correct forecast of the track of this hurricane, and somebody who should remain nameless added with a Sharpie an extension to the forecast cone. But just to illustrate, there are some difficulties with the forecasting tropical storms. One part of it is that historically, forecasting and numerical forecast models have been focused on mid to high latitude weather developments that are on a larger scale, and therefore less computing requirements were required to make this accurate. Whereas tropical storms are developing and processes are happening on a smaller scale and less difficult to calculate correctly. So if you look at the next slide, there's one solution to conquer this is using probability forecasting, where you, with the same model, run it a lot of different times with slightly adjusted starting conditions and physical processes in the model, and you get a sense of the sensitivity in the forecast. Just does a small change everything. So you get a way to quantify the uncertainty of your forecast. And in the image below, you can see the forecasted wave height and the associated spread of how worse and how good it could be. And if we look at the next slide, we can see how we can use this. Here we have an ensemble forecast or probability forecast of a tropical storm. The black line is what we call the deterministic forecast. What everybody can see is the expected track, and the coloring is the spread of possible tracks. So instead of just thinking, okay, this is going to go west-northwest heading into southeastern China, we can actually see that there's a possibility of the storm heading more westerly, but also a clear possibility that it will curve northeast and hit Japan. So here we have a lot of different information saying, okay, we now have a better idea of the span of possibilities. So we have reduced the uncertainty a bit, but we have we still have some uncertainty, but we have a better idea of what the possible track. And I mentioned the focus previously on large scale processes, and therefore historically the quality of forecasting for tropical storm has been difficult. But I can say that statistics say that the forecast accuracy of a tropical storm 48 hours ahead, 2 days. In the early 90s, the accuracy was on average with an error of 200 nautical miles or more. In the 19th, forecast improved, and errors were between 100 and 200 nautical miles. But since then, forecast models have improved, both regarding access to more satellite measurements of the conditions, the actual conditions, a better understanding of the physical processes to fill into your model. But as the primary pusher for this is the high increase in computing power. It's simply impossible to downscale to a much higher resolution to get all these small scale processes and have the computing power to calculate this for every time step for every 2-3 seconds, many days ahead. And then therefore we have for the last many years have had forecast accuracy of the position 48 hours ahead, somewhere on average between 50 and 75 nautical miles. Of course, there's still some, as I mentioned, some uncertainty both regarding track, but also the developing the intensity of what's going to happen, which are important. If we take the next slide, we have the defined categories of tropical depressions to storm and the 5 categories of hurricanes. And you can say, okay, at what level do we have a threat? Well, it depends where you are, what you can handle. But most will be in trouble with conditions at hurricane level. Of course, at sea the issue is both the wind, but primarily the waves generated by the wind. And at sea you have often a possibility to circumnavigate or get away from the worst conditions. Hitting land, we have another situation. You just have to take it and prepare for it. So tropical storms and hurricanes are defined by the wind force, the maximum sustained winds. But I have the next slide presenting what's really the problem with tropical storms. Yeah, a statistic that is not recent, but still gives a very good picture of what the problem is. And overall, it's water on land is the main killer. Looking at the tropical storm on the other picture, you can see that north and northeast of this hurricane or tropical storm, you will have a storm surge, water being pushed towards the shore, and this will of course cause a problem, together with, especially if we have a slow-moving storm, a lot of rain. We're talking about what in Northern Europe we would consider a yearly amount of rain we can have in a path of a tropical storm. So storm surge combined with the rain in connection with a tropical storm is the real killer. Of course, wind will have an effect, can be deadly too, but it will pass, whereas the water will remain. So yeah, that's a brief introduction to tropical storms and why they're dangerous. I'll hand over to you, Stefan, and so you can explain what we can do to prepare.
Yeah, thank you very much, Carsten. Yeah, and it's some nasty bastards when they happen. That's for sure. The good thing is that most ships they are able to circumnavigate these weather systems, whereas onshore it's a completely different story. And that's where I will take the outset, and I will actually focus on the shore part and how this can impact businesses ashore, whether that's in ports or it's other types of businesses that are located inland. And here, of course, the wind has an impact, and the wind can blow off roofs, and it can take down trees and things like that can damage your assets or create utility outage or even maybe impact your supply chain. But most of the impact that you will see, at least in areas that we operate, is damage to assets. And these assets can be anything from buildings to warehouses to production facilities, heavy machinery or other infrastructure that gets damaged. Then, of course, you can also see the impacts on utilities. So if you are living in a country where, for example, power lines are above ground, you typically see electricity come out, particularly for people in the US, that's a major problem. Whereas in most places in Europe, where electricity is underground, it's a lot less severe. But things like sewage easily get overflooded when there's a lot of water, and that can impact, of course, businesses as well. One of the things that many don't consider is that you might actually live in an area where hurricanes or typhoons or similar are not present. If you live in Northern Europe, yes, you get the deep lows in the winter, but where you're probably going to see a major impact on your business is how it affects your supply chain. And here, think about if you have factories in Philippines or in Thailand that are producing parts that you need to assemble in your business, then you can have difficulties getting those when you need them if the factory is flooded or damaged by wind, or employees can't get back into the factory. But you can also see issues with the delivery. Hurricanes or typhoons or cyclones can cause delays both on port operations as well as on the sea voyage or air traffic that goes into the area where you operate. So a lot of ways that your business can be affected. And what we try to do when we talk about crisis management is how can we be as prepared as possible to counter all these things. So weather is definitely one of them. And you will see in crisis situations that weather in many cases is one of the things that impacts the severity of a crisis. So what when we talk crisis management, there's a lot of value in it, and I'm pretty sure that many of you will probably say that, yeah, but we've never had a crisis and it's never been serious, so why should we do it? And it costs a lot of money. Yes, it does require some effort to get it done, but once you have it implemented, there's a lot of value to be gained, and that value you can actually extract both before, during, and after a crisis situation. Just think about the track record that you will have if you're good at handling crisis situations. Your customers will recognize it and potentially give you more business. If you've done a proper threat and risk and impact analysis, you know what preventive actions you can take, and thereby you can even further reduce the likelihood of serious incidents. And should something happen, then you know who to notify, you know who's going to do what, you know what you're authorized to do from your management team, and you have a good and structured response plan that you have prepared when things were calm. That you can activate and you can actually go out and use, and that will lead to hopefully a faster response time, shorter time in crisis modes, less costs, and potentially also less customer impact, and thereby leading to better reputation. So there's a lot of value to be gained from having a good crisis management setup. But crisis management, that's something you need to look at now. It's not something you should look at when the crisis occurs, because it's all in the preparation. I would claim that 90 to 95% of the success from crisis management comes from how well you have prepared to deal with it once it happens. Then the last part is, of course, how skilled you are in actually dealing with the crisis situation. But it all starts with the preparation, where you analyze your business, the industry you're in, you make the risk assessment, you make the plan, you exercises, and then this becomes a continuous improvement circle where you exercise, you learn from the exercises, and you adjust. And then, should something happen, you're ready to activate your plans, act, and communicate, and in that sequence, because acting is more important than communicating. And then, once you have it all under control, you're ready to move into business continuity. You do a post-evaluation, you learn from what you did, and you adjust your plans as necessary, and then you're ready for the next one. The key here is a structured approach to get you started. And if you're in a shipping company today, you probably already have something, especially if you operate ships, because there's some regulatory requirements for what you should have in terms of plans on board your ships and your SMS plans. But for other industries, and what I see when I come out to clients is that, well, we talked about it, but we haven't really done anything. So a good structured approach to getting started is this 5-step approach that we use in calm water crisis consulting. And this takes the outset in the risk evaluation. And here we do an operational risk profile, because that is the key foundation to knowing what to do in the next steps. So without knowing your risks and the risk scenarios, you don't know what preventive actions you should possibly take. You don't know what type of response plans that you should make, and you don't know what things you should exercise your teams in once you have created your general crisis management plan. So it all starts with the risk evaluation. And if we look at the risk evaluation, I usually use 4 steps in the process that will lead me towards a risk matrix, which is the risk matrix is where we have mapped out our threat scenarios with the likelihood and the impact. But it all starts with looking at critical functions. And critical functions that could be either processes or functions in your business that are critical for you. It could be critical staff. It could be something like, let's say you have a specialist of some kind that you need to protect, or you have key client managers that sits with 70% of your business, and their relationship with clients are super important. Or software and hardware experts could also be people that you want to retain. Then you have critical infrastructure or assets. So let's say you have a critical production facility, or if you're in a port, there are certain functions in the port that are important. Buildings or warehouses, IT systems, could be many different things. Or you have also critical suppliers and supplies. So let's say you are a company that are depending on cooling water for your production facilities. If you lose that cooling water, it's going to be critical. So your water supplier is going to be a critical supplier. But it could also be other things. It could be raw materials or components that you get from factories in other parts of the world. But what is critical or important when you talk about critical function is that it needs to be something that have major impact on either your finance, your reputation, your customers, or your competitiveness. And you need to be a little bit critical, because human nature is that when you start talking to people in a company, everybody would say that what they do, that's the most important part. And that's the critical part that needs to be protected. So you need to be critical when you do that. Once we know the critical functions, we will be looking at what are the threats towards these functions. And here there's many different threats that we can look at. There's internal and external threats, and I've listed some of the threats that you can look at here. Could be something like pandemic, as we see today. That's definitely a threat. That's a threat to the staff. It's a threat to production processes, etc. It could be fatalities and lots of other stuff. The key is that once you have identified the threats, you need to map them towards the critical functions, and each critical function can have multiple threats. And then you convert that into scenarios, and these scenarios you then look at the likelihood for them to happen, and you rank them on a scale from 1 to 5, from unlikely to highly likely that they will happen. Once you've done that, you take every single scenario and then you start looking at what is the consequences if it happens. And when you look at consequences, you look at both the direct and the indirect consequences. And this is quite intensive work that you need to do, because you need to try to map out all the potential consequences. And I've given an example here of a fire in a container ship. This is just a rough list of all the consequences of such a fire. And as you can see, it's quite extensive. So how do we then rank these scenarios in terms of severity? It's going to be very difficult unless you find a common denominator. And the way that we do it is we try to convert all impacts into a money value. And then the sum of the money value is the impact that threat scenario will have for your business. You can then work with your management team as to what are the brackets that we're talking about, what is critical, what is less critical, and what is a minor impact. That will differ from business to business, how you make these money brackets, but this is the only way that you can actually compare threat scenarios and prioritize when you get into the preventive action parts, where you probably need to prioritize because you can't do everything in one go. Then with this, you know where to start to get most value for money. Once you've done the assessment of the consequences, you can move in and map it into your risk matrix, and you can see how they fare out in likelihood for happening versus the business impact. And following that, you need to take a discussion with your management team as to what risk appetite do you actually have. So let's say you have a high risk appetite, you might actually accept that you have maybe a lot of threat scenarios in the yellow and green area. Whereas if you're risk adverse, you might only want things in the green area, and you will do everything you can to actually move them down, either by reducing the impact should it happen, or taking actions to reduce the likelihood of them happening. And then you can work with your preventive actions to reduce the risk level, and then recalculate and find and end up with a risk matrix that you think is important. So once you have the risk matrix, you can start doing preventive actions. And preventive actions can be maybe a second supplier of critical parts that you get produced somewhere in Asia, or it could be a second way of getting things transported, or it could be a split the storage facility into two, or your warehouses into two. There's many different actions that you can actually take here. Once you've done that, you need to start working on the crisis plan. And the crisis plan that has a general crisis plan that covers the entirety of your business, and then you have detailed response plan. A crisis plan is not something that you can just make a generic one and then think that it fits anybody. This is something that needs to be tailored to your specific company, and based on your risk matrix, also include the relevant response plans that you need. There's not a one-size-fits-all, as I said, but as you can see on the right-hand side on the slide, then there's a certain parts that are quite mandatory in any good crisis management plan, and then there's some optional stuff that you can add in. And the list is not complete. There will be other things depending on your industry and your type of business. But in the mandatory part, you need something about the crisis organization, the mandate, how you notify, how you activate the response plans, how you communicate, who's doing what. These kind of things, they are the things that needs to be in your crisis plan. When you then start implementing in your business, it depends a lot on how you do it, how successful you're going to be. So the way that I recommend you to do is, first of all, make sure if you're responsible for implementing a crisis system in your business, that it is anchored with your management. Without management support for this, and this should be from senior management and further down, you will never be successful, because we want something that is implemented that everybody will comply to afterwards. So get a clear mandate of how wide you can go with your crisis management plan and your response plan, and make sure the mandate for the crisis team is also reflected in the crisis plan. And then start talking to everybody that is relevant. So do a decent and proper stakeholder mapping, and then start talking to everybody and get their opinions and their views, and also talk to those that are critical, because they can actually become your ambassadors at a later stage if you do it right. And I recommend you take the outset in what works instead of take the outset in what doesn't work. You typically get people more engaged when they can talk about the good things, and when they talk about the good things, they are also talking about the things that are not working, and that way you actually get also those parts flushed out. It's always a good idea to get people to talk about how things would be when we are done, right? So get them to envision how their life would look when the new crisis setup is implemented and everything is running, because that's a good way to get them started. There's a model here that I've shown that comes from a company called Acuity World here in Denmark, that takes the outset in the present state and moves towards a desired state, and you have a much better dialogue if you start from the positives rather than the negatives. And then you need to talk about it all the way through the process, and you're probably going to repeat yourself multiple times to make sure that the message gets across. And if you're in a global organization or in an organization on different locations, make sure you get out there and you talk about it, and of course also when we get it implemented, that you start exercising it. And exercising, that's the key. So if you want to excel, then you need to exercise. And it's not different than any good athletes. If you want to be good at something, you need to exercise it. And when we talk exercises in crisis management, we basically talk about 3 different types. So there's procedural exercises, which are the small exercises that you do on a regular basis, maybe even weekly, where you exercise smaller parts of your crisis management process. So that could be the activation process, or the notification, or the assessment of severity of a crisis situation. These kind of things could be what you exercise in procedural exercise. This is not different from what you do on a ship when you also do fire drills and these kind of things. Then you have the scenario-based, which is kind of a tabletop exercise where you do a brown envelope and you try to do a larger scenario without necessarily having assets involved. Whereas a full-scale exercise, that's an exercise where you have all the assets involved, and you actually maybe not setting fire to a building, but you basically do everything else like you would do in a real scenario. How frequent should you do it? Well, you should do it frequently enough to satisfy the skill level that you want. And I would say that a scenario-based minimum once a year, a full-scale minimum every second year, that would be my recommendations. And like with real-life scenarios, do a post-exercise evaluation so that you take the learnings away from the exercise and make sure that if needed, that you adjust your plans. And the last part on the training side is that, of course, you need to make sure that those that are involved on a day-to-day basis in crisis management, that they are also trained and that they get expert insights in how to deal with crisis management. So with that, I'm going to round it off with this one. And can you afford doing nothing? One of the things that is pretty clear if you look back over recent years is that the requirement for readiness of a company is just increasing. And you see more and more cases of customers actually asking you for your crisis plan. So how does it look? How prepared are you? Because everybody wants to have that resilience through their supply chain, making sure that if something happens, okay, we know how to do it, but does our suppliers also know how to do it? And the gap fillers here, that's the risk insights, it's the crisis plans, it's the exercises, and of course, that you also internally in your company have the awareness of what to do. So this rounds off my part, and I apologize if our pictures is just across the mail address for Carsten, but you're more than happy to contact us afterwards and talk more about the 2 topics. And with that, I'll open the floor to questions. If you have any questions to me or to Carsten, please write them in the Ask a Question button at the bottom. Seems like it was pretty clear. So I have nothing more from my side. Carsten, you have anything you want to add here towards the end?
Well, maybe just a detail about this being the most activity we had in a tropical season. There are small indications. This is, of course, only 1 year, but there are small indications that with a bit warmer climate, we'll get larger areas and longer periods with high sea surface temperatures. So we are heading to a bit more frequent tropical storm seasons.
Yeah, that's a little bit scary, but yeah, if you're prepared, it should be a piece of cake, right?
Yeah.
Excellent. It doesn't seem like there's any questions. Then I think we're just going to close it here. Thank you very much, and thanks for joining.